Welcome to the Modern Agent series. This is a sub-series where we learn about advanced multi-agent routing orchestration. This is part 2. Alright, so since this is part 2, I'm going to go over this whole structure very quickly. And if you notice that we brought in this new guy here, the unknown agent, just in case our mission control failed to determine which agent to send it to, it's going to go ahead and send it to this unknown agent. So basically what's going to happen is we're going to have a smart mission controller, which will take the input from the user or the user message and then analyze it. And based on that analysis, it's going to go ahead and create this decision object, which will have intention, and intention will carry a string, either CRM, stock, email, research, or unknown. One of these 5. And then it will have the context, which is the user message. And based on its analysis, is going to go ahead and generate a confidence level, which will range from 0 to 1. Once this decision object is made, it's going to go ahead and hand it over to this router node, which is another smart agent, and it's going to go ahead and analyze this object and read from a routing map and determine the perfect agent for that context. And this router node will be connected to the rest of the graph via this conditional edge, and this conditional edge will be responsible for rerouting the traffic to the perfect agent, and at the same time it's going to go ahead and carry the state with it. And from this state, our corresponding agent will receive all the necessary messages it needs to do its work. With that said, in the last video, we went ahead and created a base structure for our mission controller. This time, we're going to go ahead and improve upon that one using prompt engineering. And at the same time, we're going to give it a capability to generate a structured output. That said, let's go to the code. All right, so as usual, this is my basic installations, LangChain, LangGraph, and then my model creation functions. And here we have the latest LangChain version 0.3.19 and LangGraph version 0.2.74. And here, as usual, I'm just loading up all my API keys. Just this block here will connect us to the LangSmith portal. That said, let's get started with our mission control. All right, so we are pretty familiar with our imports here. TypeDict annotated for typing, and then Chat OpenAI, Chat Google, Chat Anthropic. These are for model creation or LLM creation. And then state graph and end node for our graph structure. Add messages is the reducer function that's going to add messages to our graph. And human message and system message from LangChain schema so that we can organize our message structure. And the only new guy coming in here is the Pydantic base model, is because this time we're going to structure our decision object much better, because we're actually going for a structured output, and that's why we have our JSON imported here too. And the reason being, Pydantic is a much better and stronger library than TypeDict because it actually validates data during runtime. That said, let's move forward. As usual, we start by creating our state by extending TypeDict and the message annotated as list using the add messages reducer function. Then we make our graph builder by instantiating state graph with state. And these were pretty much the same, but here comes the new stuff. Remember, I mentioned stronger prompt engineering, and that's what's happening right here. We are implementing a much better, more elaborate system prompt here, and these ones with examples are called few-shot prompt templates. And few-shot meaning when we describe something to our model, if we give a certain example, it makes it much stronger and we get more accurate answers, right? Here we're saying you are mission control responsible for analyzing user input and determining the correct intent. Your only task is to classify the query into one of the following categories. So here we are describing the categories as stock, CRM, email, research, unknown, and at the same time we're giving the model examples to work with. For example, especially in this case when it's unknown, we're giving the example questions that will help our model understand to categorize the unknown ones. Kind of like, what is the meaning of life? Tell me a joke. I mean, these kind of questions we're not ready to answer here, right? And that's the reason we're providing all these categories. And then we're making it even stronger with extra guidelines saying only classify the request. Do not generate an answer or provide additional reasoning. Because as we know, working with AI models, when they describe something, they like to talk a little bit more. They like to explain things, right? So here since we are going for a specific data structure, we're telling it not to do so. We don't need any other mumbo jumbo by you, right? Just give us the exact answer. And then we augment it by saying return exactly one of these labels: stock, CRM, email, research, or unknown. Stay very specific and use only these strings. If unsure, default to unknown and do not attempt to guess. See, this is how we are pretty much telling it not to hallucinate. Your output must follow this structured format, and we're giving it the exact structure we were asking for: intention, context, and confidence. And confidence score will be between 0 and 1. And now we go ahead and create our models. Now here I have the ChatGPT 401, with which I had 100% success, so I'm not even going to test it. So this guy can just wait here. In this case, you're probably noticing that we're missing our DeepSeek R1 llama model, because that guy actually failed to generate structured output, so he's out. So in here we're bringing in these Gemini models. I have already tested this Gemini 2 Flash, which is almost exactly equal to ChatGPT 4.0, if not better. I was extremely impressed, but these two I haven't tested yet. Here is a Gemini 2 Flash Thinking model and Gemini 2 Pro model, and I have done other testing on this, and once again I was very impressed, and I can tell you both of these are better than both Gemini 2 Flash and GPT 4.0. In some cases, I have noticed that Pro and Flash Thinking gave me better answer than even O3 Mini or O3 Mini High. So this time we're going to test those, and we're going to bring in also Claude 3.5 Sonnet in here just to test to see if this can generate structured output, because that's the main test here. All right, so now moving on. As mentioned before, we are using Pydantic base model. Basically, this is going to be the parent class we're extending to create our decision object, and intention will be string, context will be string, and confidence will be float, because it's going to be a decimal point number. And in here, this is going to be something new to lots of you, because here we're not just going to create our LLM, we're going to create our LLM with a function called with structured output. LLM dot structured output, and then we're passing the decision, and now we have a new LLM called structured LLM. This guy now should be capable of generating structured output just like mentioned here, and it's not going to be a string, by the way. That's the specialty here of this function. All right, so here we build our mission control node. Just like before, we have our messages object, messages dictionary with a system message. This is where we pass our mission control prompt as the system prompt, and we also include the user's message as human message. But additionally, this is what we're going to do here. We're going to go ahead and invoke our structured LLM dot invoke with this message, not just LLM. And that's what will give us a structured output right here. And then finally, we're going to return or add to our messages in our graph state with this AI message, content equals JSON dump output.model dump. And these functions are coming from Pydantic to maintain our data structure. With that, we just finish creating our mission control node, and then with the graph builder.add node, we just add our mission control to the graph as a node, and then simply as a starting point and ending point set same mission control to keep it simple and testable. After that, as usual, graph builder.compile, we have our graph. Let's run that, and boom, we're ready to go, ready for testing. All right, so we are now going to test everything. So let's go back and see what was our model again. All right, so this time let's start with this guy right here. This is the thinking model, because so far with the thinking models, I had no success when it comes to structured output. None of the O1 models could do it. DeepSeek R1 Llama couldn't do it. So let's see if this guy can, because remember, this is one of the main important criterias when it comes to agentic orchestration. So I'm gonna run it again. So now we have the Gemini thinking model, Gemini Flash thinking model. So let's try with this question here, and here we're not gonna just put the output. We're also gonna see what the output type is, right? Because we're gonna expect a dictionary output, which is a JSON. Because before, in the last video, we saw nothing but string, right? So let's run it. Boom, there you go. As usual, it fails. So blah, 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 function calling not enabled. I mean, you know, they complain about a lot of stuff, but so far the thinking models are not ready for this. Maybe I should put it other way, that LangGraph needs to come up with or LangGraph or LangChain needs to come up with better function to deal with these thinking guys, right? So that being said, let's go ahead and try our Gemini 2 Pro guy. Disable this one, and okay, I have to run this. Okay, now same question. Can you find more about LangChain? And we're using Gemini 2 Pro. Boom, there you go. It's successful, and look at the confidence level, 100%. Intention is research. And look at the data type. It's the data dictionary. So we have a perfect output. It's ready to be handed over to our router. That said, let's go with the next question. Can you get me, can you get me my contact list, right? Let's see what that is. Boom, CRM, 100% sure. Please message Michael. This should be email, and it is. But see, as the please message Michael, it's sort of vague. Look at the confidence level drop, right? That's kind of nice. All right, so, and once again, the stock one, we're also intentionally keeping it vague. So let's look at the confidence level. So this should be stock, and let's look at the confidence level. Stock context 0.9, not bad, not bad. Also a dictionary, and let's give it a question. What should I do with my life? Oh, it's 100% sure it's an unknown. And you know why? Because of all those few shot prompting, because we have examples so that it knows exactly what to do with it, right? Now let's go test out the Claude Sonnet. All right, so we disabled all the Gemini stuff and enabled chat Anthropic. So let's run it. Okay, we're ready. And now let's go from bottom to top, right? So let's start with the vague, what should I do with my life question. Let's see what Claude does. Wow, it's slow as heck. Wow, took such a long time, but it did answer correctly. All right, so let's go and give it another vague question, but this time I'll probably cut down the time. So let's go. Wow, it was quicker. Nice. Okay, so it is stock, and it's 95% sure. So let's go and give it another vague question. Please message Michael. Taking heck of a lot longer, and it failed. It failed to process. I mean, at least last time I tested these Claude models, they were pretty good with this, but now look at this. It failed after taking so much time. So this is definitely out. With that, I'm gonna go ahead and conclude this video. Thanks for watching.